So we're going to start by finding the Laplace of a constant. A is a constant. We're going to transform that ft, which is equal to a, to Laplace function. We will start with writing the expression for Laplace, and that we say the Laplace with the open square bracket, the function of ft, close square bracket, will be equal to the Laplace open square bracket a, replacing the ft with a, and that will be equal to the semi-integral 0 to infinity, the function ft, function of ft, times e to the power of minus st dt, which I can then replace the ft with a, so I can write it again as 0 to infinity a e to power minus st dt. And so that's what we have to integrate. And to integrate, because a is a constant, we can bring it out. Integral of 0 to infinity e to power minus st dt. And if we integrate exponential function, we get exponential function back. So that would be a e to power minus st. And then we need to divide it by the differential of the exponent. This is the exponent here. If we differentiate the exponent, we shall get minus s. So we divide it by the differential of the exponent, which is minus s. And we are integrating over the range of 0 to infinity. And so we can then replace t with infinity and t with 0. So we have a, the constant, and we need to bring minus s out. So that'll be minus over s. Let's do open bracket. We're going to have e to power minus s times infinity minus, we need to do it for 0 now, e to power minus s times 0, close bracket. And that will be minus a over s, open bracket, that would be 1 over e to s infinity. If that goes to infinity, 1 over infinity would then go towards 0. So that would be 0 minus, where 0 times s is going to be e to 0. As you can see, we're going to get the minus a over s. This will be 0. That will be 0 minus e to power 0 is 1. And that can be written as minus a over s times minus 1. And that should give a over s. I've now got the Laplace for a constant. Laplace, let's just do that. For a constant, a will be equal to a over s. So this is the first derivation for the Laplace of a constant. Laplace of 1 will be 1 over s. Laplace of 2 will be 2 over s. Laplace of 3 will be 3 over s.